Our esteemed speaker this evening has over 25 years of technology experience. He was Security Technology Monitor's one of top 10 CIOs on Wall Street. Please welcome the founder and CEO of 60s Technologies, Jeffrey Birnbaum.
Okay. I think we have some really exciting stuff to talk to you about today. How many of you, a show of hands, quickly, how many of you have ever heard of AMPS? Okay, that's awesome. Okay, so my job is to explain to you, okay, one aspect of what AMPS is, and along the path, tell you a bunch of other cool things that the thing does. How many of you have heard of Kafka? Good. So we're going to show you how we blow it away. So if you're using it, it's great. How many of you heard of Redis or Redis? Good. How about RabbitMQ? Or any other queuing system like MQ series? Awesome. Okay, so I'm about to show you a complete and absolute rethinking of some of these topics. And I'll try to point out why it actually matters. Okay? And along the path, I'm going to try to point out, although maybe a little bit disjoint, although I don't like to bash other products, the way I'm going to end up doing it is basically tell you about problems that exist and why it would be difficult to solve those problems with those technologies, even though those technologies can solve lots of problems. Okay? But I think they're actually quite limited. So most of you know what message queues are. They've been around for 20, 30 years, and they're actually pretty boring in a lot of senses. And I think we've tried to reinvent them. And that's what I'm going to be talking to you specifically about tonight, even though AMPS, PACS, got 5-ish real big features. What are we? We are a pub subsystem. We're integrated with a NoSQL SQL database. That's a mouthful. We have an aggregation engine where you can do joins and projections of new data. We have this queue capability. We do a host of other things that are quite interesting, but we're going to focus today on queues. And by the way, at the bottom of the t-shirt, it does not say UFO. Okay? That says version 5.0. That's what we're talking about today, version 5.0 of AMPS. All right. Just some quick credits. We're not going to spend time on this. Nobody wants to know about this. We've basically been building the software for a few years. My co-founder is here, Brand Hunt, he's in the back. So if you find him afterwards, please spend some time with him. We have a good number of people in the company that have a broad experience. So that's not what I want to talk about. I want to talk about rethinking message queues. So today, how many of you actually use message queues and what you do? Or use anything approaching message queues? Okay, a fair number of you. Good. So I think a lot of what I'm going to tell you is going to resonate with you. First of all, queues are very good for, let's talk about what queues are different from PubSub. PubSub is I have a message and I want to disseminate that message to a wide variety of people that may express interest. Most publish subscribe systems offer you pretty vanilla topic spaces. It was an order, it was an execution, it was a position, it was something, but that's about it. All orders, you get them all. Okay? So in AMPS, one of our philosophies is we want to actually take the burden away from the application and only deliver the data that the app actually wants. So I want all orders where status open and account is 1, 2, 3. Okay? We will only deliver you those orders. So that's a where clause. That's a SQL where clause, just like you could query a database. Okay? We're going to bring some of those same capabilities to queues, which nobody does. Nobody does the stuff that I'm going to talk to you about today. Another problem with queues is that queues typically have a put-get model. Okay, so first of all, the thing that makes a queue different than PubSub is queues, you drive data in, and then you deliver it to one person, okay, one consumer. So it's a little bit different. The idea is that you usually have some load-balanced system, and each of them are taking a piece of it and concurrently working. But therein lies some of the problems with queues. It's typically a put-get system. I put stuff in, I get stuff. And when I'm done with something, I go back and get more. Okay? That's inherently slow. Okay, it's not very concurrent, it's very slow. So we're talking about how we solve that, how we rethink that, okay? And a host of other things. And I probably have like 30 some slides. I'm not really a slide person, okay? And I'll probably get through 15 slides and then we're gonna be done. That's just the way it goes. And please, if you have a quick question or want a point of clarification, ask it. If I think it's distracting, I'm just gonna move on, okay? If I think it's actually a really great question, okay? Yeah, I'll give you a high five. Okay, so this slide typically just talks about why you would actually use message queues. The best example I can give of message queues are, I've got 1,000 workers, right, in some compute farm, and I basically have work and I want to distribute that work in a reasonably fair way, okay? Lots of people build what they call grids, right, to do this. So I'm a credit card processor or whatever. I just want to take work. This credit check may take 10 seconds, it may take a minute, it may take whatever. It's disjoint, right? Some of them may be quick. So the load, the workload is maybe a little different, but you want basically as many workers as you can get. And as you add more workers, you want the processing to go faster. So if I've only got 10 processors and I'm processing the data in the queue, I may want to go to 1,000. Okay, and do that. So that's the main reason to use queues. All right, I think I got that. Rethinking queues. Okay, first of all, basic put and get. Got to break that philosophy. It's not high performance. So imagine you get a message, you process the message, and then you go back and you get the next one. Okay, why is that bad? Why is that bad? Is because while you were doing that, the system could have been sending you another message, okay? So you can get some level of concurrency, right? So that you don't have to wait. Imagine all the waiting you're gonna do. So I sit there, I get a message, I process it, I send back, okay? Now, some type of connection has to talk back to the thing has to say, oh, you want another message, come back. And then what most queuing systems do is even worse, is they have, almost think of a linked list, right? Everybody's trying to take the last thing. So you have 10 consumers all coming to get at the same time. And now it has to fight and basically use some kind of locking structure to lock the top of that queue, right, or the head of the queue to pull it, okay? That's not good, okay? So that's problem number one. I don't know if we'll go there too deep into this, but HA is a real problem. So imagine you have a queue and you actually want that queue spread across New York and London. So I have London users, I have New York users because I have some spare capacity in London, right? And what I want to do is I only want those guys to process messages from the New York instance, okay, when I have nobody in New York ready to process. So so that's a replication thing. I need to replicate the messages, and how do you do that in a nice way, okay? Our search of every queuing system on the planet basically showed that nobody solves that problem well. So that was the next problem that we looked to tackle, okay? The next is selectivity, okay? So how do you set up a queue? Typically in MQ series or RabbitMQ, you set up a queue. And that's, in and of itself, that is the problem, okay? So I decided early on that my queue is orders and executions, positions, P&L, whatever it is, okay? Somebody writes a message to the queue and somebody takes a message from the queue, okay? Once you take the message from the queue, it's destructive. The message is no longer there, okay? It doesn't exist anymore. Well, what if you want to say, you know what, I want to do a replay of all of those messages. I need to test again, right? The queue's gone, okay? So that's another problem that we've looked at. How do we solve that problem, okay? Let's see. Okay. The other thing is queues, as I've mentioned and I'll point out many times, they're slow. So one of the goals that we did when we tried to reinvent this is make them actually really fast. And I'll show a slide that says something like, not tens of thousands or 5,000 messages a second, but we're talking hundreds of thousands, like 200,000, 400,000, 500,000 messages a second through a queuing system, okay? We're going to talk about how a queue is composed. In AMPS, when you set up a queue, you give it a name, and then you say, what is it receiving? So think of it as a funnel into it, okay? And this breaks some of the decoupling that we see in existing queuing systems. So let me give you a good example. let's say that I decide I want a queue, and I want this queue to contain all orders that are open, that are status equal open, and they're in account ABC. So I've set up the private queue just for this one guy to process. So in AMPS, what you do is you basically set up your queue definition and basically give it a subscription. That's what we're doing. We're saying the queue is actually a subscription to data, and it may come from various topics. It doesn't have to come from a single topic. So the cool thing about this is, imagine you have data that comes in, and you actually want that data to appear in 3 queues. In current queuing systems, there's no way to do that. You have to have 3 distinct queues. That's what you do, an A, a B, and a C. Okay, and I'll show this in an example soon. And what I really would like is I'd like me to be able to publish to A, and maybe it goes into 3 different queues, because that's the way I've decided I want the work partitioned. Okay? Also, what's the number one thing you do when you have a queue? Okay, from an administrative or operational perspective, or even you just want to see. You go and get queue depth. Okay? What is interesting about queue depth? It's a trick question.
Processing delay?
Nothing. There is nothing interesting about queue depth. What does it tell you? Does it tell you how much P&L? Does it tell you how much P&L you have sitting in the queue? Does it tell how many orders from your most important customer are sitting in the queue? No. It tells you how many things are in the queue, which is almost meaningless. Okay? So we're going to talk about how we built into this product a way to actually see semantically what's in the queue in whatever way you want. Okay? Let's talk about fairness. How do most queues distribute load? Okay? Most of them are round robin. I give it to this guy, I give it to this guy, I give it to this guy, I give it to that guy. Okay? That's not very interesting. Okay? What if I know that this guy has the least amount of load? I should send it to him, right? He's got the best chance of actually processing it. So we'll talk about these things called fairness models that we've built into it. And then of course, because we're SQL based, right, from a perspective, we can also do entitlement access. There's a lot more stuff that we've invented, I think. Lease expirations. I send a message to you, okay? You process the message and you die, okay? That message, it can't be acknowledged. It's sitting in the queue. So what do you want to do, right? That thing's never going to come back, or maybe it's not going to come back for a long time. You maybe want to say, you know what? You didn't process it in a lease period. I want to send it to somebody else, right? Okay? So I don't miss things. All right. Let's go. Okay. I mentioned this earlier. Okay? I want to get to some actually diagrams because I think it actually brings more to it. Our queues are designed for really, really high performance. So I'll talk about some numbers. I think there's actually a number here. Here it is. We've been testing against both Kafka and RabbitMQ. And there's a lot of differences between these products because one of the things that those products don't have is they have no ability to filter. So there's no way to say, hey, I'd like to get messages from the queue, but I only want to get the messages where the notional value of the bond is greater than 1 million. Okay? No, you have to go and just get a message from that queue. You can't decide, I only want a certain subset of the messages. Okay, so we have that. So even if you pair that away, you just do get from the queue, if you will. Okay? We're talking about, when we compare ourselves to something like RabbitMQ, which is the obvious straight example, we're talking doing close to 500,000 messages a second. And what's really interesting about RabbitMQ is no matter what we did with RabbitMQ, we got 17,000, 18,000 messages a second. It didn't matter whether we ran 1 publisher, 1 subscriber, 8 publishers, 8 subscribers, it was 17,000 or 18,000 messages a second. Okay? That doesn't even make sense to me. Actually, it does make a lot of sense when you look at it on HTOP or TOP, whatever you like to use. From a CPU processing, you see it's using 1 or 2 CPUs. So basically, it's basically single-threaded. So you're never going to do well. Our thing is not. So it will use more of the machine, but it will use it wisely. Yeah, question in the back? No? Good. All right. This is a really busy slide, but it talks to a lot of what I'm describing. We have a couple publishers. They're publishing to different topics. Okay? Okay? We have messages that go inside AMPs, they go into a singular transaction log. So all messages, okay, are being written into this transaction log. It's persistent memory, persistent on disk, okay? The little boxes below are the different topics. So A was a publish to topic 1. Okay, B was a publish to, again, topic 1. And then what we're showing is 2 different queues, and the queues have been set up to take from different topics. So you can see that, I think I read this right, from topic 2, right, we're getting all of these messages, okay? And then from topic star, from all the topics where the type is, what does it say, A or B, okay? Just believe me, it actually works. And now you're getting 2 different queues, okay? The publishers have no idea what the queues look like. Again, that's completely different than any other queuing system, where when I publish a message, I write it to a queue. That's all I do. Highly coupling, right? I write it to queue, people have to take from that queue. Here, actually the publishers have no idea what the queue definitions are. Right? That's a break from traditional systems immediately. But I'm filling up 2 different queues. So what is a queue really? It's an abstraction, right? It's an ordering property. So we're building this view, if you will, inside the server of what actually the contents of the queue really are. Okay?
So how the users
Can you
know
go back?
which of these subjects are coming from?
They will know. I will tell you. Okay. Now, also, our queues allow you to get messages from the queue, but you can get selectively. So for example, I don't have to just get the next message. I only want to get messages that match some criteria. So I may be, for example, let's say I have something where I set up 2 computers and they're going to process all the high value trades, whatever that means. And then I have 10 other workers that are handling all the low value trades. So I'm trying to keep the load light and only process high value things on these 2 computers. These are my high value customers. So what I'm going to do is I'm going to subscribe to the queue, and I'm going to say, I want you to give me all the messages, right, where value is high, whatever that means, okay? Everybody else is going to get everything that's not that. Okay, make sense? Okay? So that's when you get this. You basically get filtering with queues. And what we can see here is I have a publisher that's publishing messages into the queue. There's a filter that's filtering what he publishes. So only messages where the type is in A or B go into the queue. But now my subscribers all are taking different parts. And remember, they only get one of them, right? So any one message only goes to one of them. That make sense? So the first thing to do is we have to say, okay, the A1 message, does it match subscriber 1? Does it match subscriber 2? Does it match subscriber 3? Oh, it matches only this guy. Okay, send it to him. The next thing says, if it matches all 3, I have to pick which one I send it to. Okay, now I have a decision to make, because I can choose any of them. And we talked earlier, and I'll come back to it, about these fairness models. So that's where a fairness model comes in. Who should I deliver it to? Okay? Did everybody get this slide?
Is this a push mechanism or the pull the subscriber asked for?
It's an awesome question. We've reversed the polarity, and it is a push model. But the push is interesting, is that we push, every subscriber comes in with what we call a backlog. So if you want to operate with like a traditional queue, backlog is 1. That means I only have the ability to receive 1 message. Okay, make sense? The cool thing about that is, and I'll get to it in a little bit, if you open up that backlog a little bit, you can get a lot of concurrency. Just open it up to 10. That means I can send up to 10 before he's not available for me to send to. Okay, and the way they decrease their backlog is when they're done, they act it. But the cool thing about a backlog, if you think about it, I sent you 10 things, you're processing 1, 2, 3, 4, 5, you act those, I can send you 5 more while you still got the other 5 to process.
So it's
you're
like
getting
a
a high degree of
Cupid's
concurrency. What?
Is it like Cupid's read ahead kind of a thing?
No, the read ahead actually is brain dead. Okay? Because what the read ahead is basically, the idea is this. So they have a traditional put get model, and what they do is they go and they say, hey, give me a batch, give me 100 things, and I'll grab 100 things. The problem is with that is you haven't got any concurrency. I process 100 things, and now I have to go, I'm done. Now I'm not doing anything other than making a request to go get another 100 things. So there's no concurrency there. So that's a batch model. That's not what we're going to call a smart pipelining model, which is what we're calling it. All right.
I'm sorry, so that flow control mechanism you were just talking about,
Which flow control?
So give me 10 messages, I act 5, now I have room left in my window for another 5. Is that implemented, is that TCP doing that?
No, that's our code doing that. That's our code. We're basically, when you subscribe, you can subscribe with a backlog. Okay? You can subscribe with a backlog of 1, you can subscribe with a backlog of 1,000,000. Okay? Which means you're available for me to send to you as long as you have available backlog, and we're tracking the backlog. Okay? That's what we're doing. Okay. Okay, the next thing is, remember I asked you that question? Okay, what's so interesting about queue depth? And I said nothing. Okay, this is our answer to why queue depth is not interesting. We have a queue, a bunch of stuff comes in, goes out, okay? The contents of the queue are constantly changing. If you want to monitor that in sort of a business rules way, right, or aggregate the information, you can do that. Our product has this concept of views, which are basically similar to SQL materialized views, where you're basically aggregating the contents of a state of the world, in AMP's case. We're not going to talk about that today. But we actually can do the same thing on queues. We can actually treat the queue like it is a state of the world and aggregate it, okay, up. So in this case, I've defined a bunch of different views on this queue, right, that are pretty simplistic. And what I've done there is now I've produced new data that other people can subscribe to or query, right? So in AMPs, everything is you either query, you query and subscribe, or you subscribe. So as that data changes in real time, you could be subscribed to it. So you could have a real-time monitor of, let's say that my favorite customer is FUBAR. And I'm really concerned about the number of outstanding things in the queue for FUBAR. I could actually monitor, okay, with a view, how many things by customer ID or whatever it be, right? And then I can see, maybe in a bar chart or something, which clients have what. And if I don't like it, maybe I'll bring on some new engines with subscriptions just for those messages. And it actually can race ahead, which is very cool, okay? It's something I haven't described yet. So imagine, I should actually delve into that for a second. So if I have a queue, and I subscribe, if I'm a subscriber A, right, and I say, give me all the things where status equal open, okay? And I'm B, and I say, give me all the things that are closed, okay? Messages are interspersed in the queue, open and closed, open, closed, open, 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 closed, blah, 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 right? So I have all these things. The coolest thing about the way AMPs works is every time you generate a subscription to AMPs, it starts at the top of the queue or the bottom of the queue, however you want to think about it, right? The oldest message, okay? And it basically walks forward, okay? So instead of the get operation where you just try to get the end of the queue or the top of the queue, I don't know how you think about this, but you try to get something. Instead, what we're doing is every time you subscribe, we go back to the front and we just start saying, oh, I have a thing here, let me see if that matches you. Oh, we have a thing here, let me see if that matches you. Okay? Simultaneously, another guy can come in who's got a completely different subscription, and he can be doing that same thing, right? And so you can actually get concurrency of message delivery without having like a single process that says, hey, does this match this one? Hey, does this match? Oh, which one does it match? Actually, you got multiple of these going on at the same time, okay? As long as we don't have them interfere with each other, and we have all the techniques to do all that stuff. Does this make sense? You guys getting this? It's not that hard, but it's really, really powerfully cool. Imagine now, you say you're, whatever, all I've got is queue depth. I know I've got 1,000,000 things, but I have no idea what they are. Now you can say, I've got 1,000,000 things, and 25,000 of them are things I really care about. So let me bring on a new process, let me put a subscription on there, and the coolest thing is it goes right to the last, oldest message and starts processing, right? And you're gonna now get delivered those, which is pretty darn cool. Okay. A lot of material here. Fairness model. Okay. Fairness model is quite simple. We have 3 fairness models. We have cheapest to deliver, which means, okay, I come across a message, I find out that six subscriptions match, okay, and I've got them in a list. Cheapest to deliver means take the first one, deliver it. So if that guy's always the same one and he has available backlog, he's gonna get the message, cheapest to deliver. Round robin, okay, I got 6 that match, okay, round robin says I deliver to this guy, and then I remember the fact I delivered to him. The next guy that matches, I say, oh, I wanna go to the next one, okay, blah, blah, blah. The most interesting one, the one that I believe everybody will use because it gives you load balancing, the best load balancing right out of the box, is proportional delivery. So what we do is we say, okay, I got 6 that match, who's got the least backlog? Okay, I'll find the one with the least backlog and deliver. Okay, that immediately changes the backlog equation now, because now he has 1 less that he could receive. So the next time around the next message, let's say that 2 were tied, right? 2 both had 6 backlog. I deliver to him, he's got 5, now he's got 6, next message comes in, goes to the next guy 6, okay? You just keep doing that. Every iteration is recompute, essentially resort them by backlog and deliver to the one that has the most backlog. That is a fairness model. And I am trying to move rather quick. Yeah, question?
If in this backlog model, say somebody has 5 messages there.
Yeah.
It dies at message 3.
Yeah.
What then happens to those 2 messages? Is something keeping track of the 2 messages?
Awesome question. That's leasing. So we have this idea of lease, and lease is a different than expire. Okay. So expire, I'll be quick about it. Expire is I have messages in the queue, and I don't want it to sit in the queue more than 30 seconds. So at 30 seconds, get rid of it. Take it out. It's stale. I don't want anybody processing old data. Okay. Lease is I gave you a message to process. Okay, and 20, 30, 40 seconds went by, the lease was 15 seconds. At least we'll notice that you didn't process that in 15 seconds, and we will deliver to somebody else.
And then the other one comes back up, it knows not to process that message. So say something came down and then it comes back
Well,
up.
that's always a problem. You have to choose what you do. Okay, so that's always a weird thing. So we have exactly once, at most once,
Right.
kind of semantics. You know, at least once is the most semantic that most people use, because at most once is kind of weird. But you end up with this problem sometimes where somebody says, oh, I processed the message, I'm a little late, right? I didn't pay attention, and we had to deliver it to somebody else, but that's what you wanted. Okay? Okay. So it's better than you just have to figure out what to do yourself, right? With no lease expiration. So this is fairness model. This is the proportional model, which I think will be the most popular. And we spent the most time on because it's the one that's most performance sensitive. Okay. Yeah, question.
Can you implement it in exactly once delivery?
Yeah? Yeah.
Because I'm working to this, if it fails, you don't know if it failed. How do you know it was in process then? By the
Well, once we deliver a message in that model, that's it, we're done. I mean, that's the best you can do.
and it's not acknowledged.
Well, once we deliver it, we have to assume you're going to process it. Okay, unless you just import it, right? In that case, we could deliver it to somebody else.
But
That's
it's
really not the way it gets used. Okay.
There's no unit of work in that.
That's right. That's right. Okay. HA. I don't want to delve into too much HA because it can be highly confusing, but let's just say we think we solved this problem. We filed patent for how we solved it because we think it's very, very innovative. We looked at every queuing system and tried to, this is a really hard problem, right? And here's the basic problem, okay? I've got users in New York, I've got users in London, okay? Messages are being published in both, I have a queue that's being replicated, okay? I have messages that are being published in New York, okay? And at some moment in time, all the subscribers go away. So messages are accumulating. I've got subscribers in London that match those messages, okay? What we've basically said in the system is we prefer local delivery, and we make foreign delivery, I guess bad way to say it, we far delivery, non-local delivery, to be secondary. And all it means is shortest path to deliver, whatever you want to call it. It's called fast path, slow path. So if I'm on the system where data is being published to and it's local to the instance, we prefer that delivery. Okay? So if I have New York users, London users, but I have New York publishes, and there are subscribers in New York to receive those messages, they're all going to be delivered locally. Now let's say we have these 10 messages sitting in the queue, and no one in New York has a subscription that matches, but I have somebody in London where the subscription matches. What we do in AMPS is we simply say, hey London, you request the ownership of that message. If New York grants that message, it transfers it to you. It didn't actually transfer the data was already replicated. It's just a command that goes across, okay? Then we can deliver it locally to London. If we then get a subscriber that comes into New York, right, the message actually, and let's say the London guy went away, we can transfer it back to New York and deliver it there. So what we do is, it's a fast path on the local system, and I think this is what most people want in a replicated queue. So I've set up New York to do the primary work. London is taking, say, I have a bunch of subscribers. It's a classic scenario around the clock, right? I've got New York guys, but I got to take them down for maintenance. Okay? I've got all my data being replicated over to London. Okay? When the New York stuff goes down, not the server, but when the consumers go down for maintenance, now London is basically requesting transfer of all those messages and it's getting them. It's actually not that slow. It's actually, we've actually measured it. It's pretty darn good. Okay? Does that make sense to everybody? That's HA. All right. Okay. Talked about leases a little bit. We talked about expiration. So I mentioned expiration as well. I want to leave some time for some questions. I want to go back to the smart pipelining concept. This is very key to what we're doing. Okay? We're breaking this put-get model. Put-get, I think, is evil. It's basically archaic. It's an anachronism, which is I go and get something. Okay? And then when I'm done, I go get the next thing. Okay? That's a pretty slow way to work. What you want in modern systems is you want a high degree of parallelism or concurrency. Okay? While I'm processing stuff, can the system actually detect, okay, that I've actually made some progress, right? And send me new stuff, okay? So that it's just a continuous flow and there's none of this wait states, okay? It's just like hard disk drives, right, are notorious for having wait state processing, right? They know the write to the disk is slow, so they do other things. And then when SSDs come along and that delay doesn't happen anymore, that wait state is like, there is no more wait state. And so other things don't happen and the whole thing gets messed up. Okay, your question?
Is it that now there's a traditional queue is part of the subscriber and he gets those messages delivered to that queue and the subscriber is reading from that local queue?
Say that again, I'm not sure I
See,
understand.
like say you, the whatever the AMP queue pushed like say 100 messages to the subscriber.
Yeah.
Is it that there is a queue, like traditional queue at the subscriber now?
No. No. I mean, you can think of it that way, but it's not. I mean, what we've basically done is taken a pub sub model and basically put queues on, basically put a queue delivery model into it. So instead of us waiting for you to call us to say, I want something, we send you something. You've said, I want these things, so we're going to send you them as they match you. Okay? And the coolest thing is, we can, as I said, we can proportionally deliver, we can round robin deliver, but we're trying to send stuff all the time. Yeah?
So, having experimented myself with the two models, I totally agree. This is the way to get concurrence.
Awesome.
I measure it. You're correct.
I love you.
The thing is that you need to change yourself or your clients depending on your role.
That's correct.
The paradigm of development, they have to be event-driven.
You need to make your client a lot faster
Yeah.
because you're using technology that's really slow.
And you need sometimes to change, to basically, not say,
You do.
but change your code.
You do.
to
But I think this is actually easier model to program to.
yes.
This is an easier
If
model
you
to
think
program
that
to.
this way at the
Because if you
beginning-
think of it is all I'm doing is I got a handler that's being delivered messages.
Yes.
That's all I do. I just have a handler that's getting delivered messages as opposed to, oh, I got to go fetch the next one. You don't have to do any of that. There's no more, I have to go make a call to fetch it.
Yeah. But if you wrote on your code like a get,
Yes.
you're in trouble.
Yes, that's right. Awesome. Okay, now that I've wowed you with cues. And I'm ready to answer all the questions. We just want to talk a little bit about how we do all this. Okay? The secret sauce, as we like to call it. Okay? Secret sauce is great code. No, the real secret sauce is attention to detail. So I like to talk to people about what we've done in AMPS is we've built a massively concurrent, okay, system. Okay, very few locks, almost no locks really. Highly concurrent, highly scalable, and we're breaking the 80-20 rule. So how many of you program in a traditional sense? You guys are all awesome programmers. Okay, where you think of, I want to make my stuff faster, so I get my profiler out, and I take all the stuff that's really hot, and I tune it. I would argue that's an old model. It's actually not a really great way. I mean, making that individual thing faster, yes, that's always good. What I'm going to argue for here, everything matters. In a highly concurrent system, even what you believe are background tasks that you say, I don't care. So it's actually sometimes that 20% that actually matters. Let me give you an example. I'm doing something and it requires a huge amount of parallelism to actually do in a fast way. Okay? And I need all the CPUs to actually go. I've got a bunch of background threads doing background tasks. They're not time critical, whatever. And so when I code them, I'm not saying we did this, but this is what a lot of people do. They don't care about performance. They have locking, they have, you know, expensive writes to disk, they do all kinds of stuff. And what I would argue is that 20% slow code is robbing resources from the other stuff that needs to be fast. So that the thing about it is, and the secret sauce that I can say is, we've made just about everything that we do in this product fast. We don't have any piece of code that we just say, you know what, performance doesn't matter. Actually, it all matters, especially a highly concurrent system. I want to use all 36 CPUs, okay? And I don't want some background task that's super slow, hogging up a couple of CPUs to do that stuff. It has to go on, so do it as fast as possible and get it out of the way, okay? Don't just lumber there and take away the 2 CPUs that I might need, okay? That's part of the secret sauce. The other is understanding the system, and one of the things, you know, it's kind of cool to see when we run AMPS, and we can run AMPS on a VM, we can run AMPS on a great system, okay? We can run AMPS on all manner of systems, okay? And the performance will vary depending on what you give it. But if you give it a great machine, we start up and we immediately look at the entire landscape of the machine, the NICs, the storage, everything that we have to use, and we basically optimize the way we lay out the threads, okay, and move them around, including the thread stacks. We move all the thread stacks to where we want on the right CPUs. We do all of this stuff so that when we, many of you program in Java, and you know that the GC adds lots of jitter to whatever you do, and it's gotten better, but it's still there. So imagine it's the same concept. In a classic 2-socket NUMA machine where I've got one with 18 cores and another with 18 cores, you have extreme NUMA effects, where if I actually have data on this node and I try to access it from the other node, you get nonlinear performance. That's why it's called NUMA, non-uniform memory access. And actually, you can get major burps, just like GCs, for doing that. So you want to be smart about how you lay things out in the memory, and we've done all that stuff. And we've built a product that's insanely fast and scalable. Okay. You want to add anything?
Do
Questions?
you keep all the messaging data on the flash drive?
What's that?
Do you process all the messaging queue on the flash drive? I mean, sorry.
On the flash drive?
Not flash drive, on the like a solid state disk.
AMPS will run on anything.
Or hard disk.
AMPS will run on anything. If you tell me that I have a spinning piece of rust, okay, as long as it works, I guarantee I can probably get 100,000 messages a second out of it. Okay, believe it or not. Okay, because the code, we just built the code, again, for high level of concurrency to be smart about stuff. Okay, maybe if you wanted the absolute lowest latency, right, on a per message basis, I have to tweak that down to say 20,000 messages a second. Okay, and there's always a trade-off between latency and throughput and whatnot. And we've tried to design for both, but it's not always possible. Now, if you tell me that you replace that spinning Rust with a SATA SSD, we're gonna maybe go to 300,000 or 200,000. If you tell me that I got a fancy, well, it's not so fancy these days, but a PCIe SSD, I can probably get to 800,000, okay? So we take advantage of what's there. So we write our code to work well in all of those, but it doesn't require any of those to get great performance. Just like if you tell me I've only got a VM with 4 CPUs, amps will work just fine, okay? It will tune to the hardware, and we like to say it scales up and down. So, other questions?
Can you talk about the subscriptions a little bit, or are they
Subscriptions?
or is that by the API?
Subscriptions are basically like you're querying a database. Think of it as a real-time query. So we have a couple of commands in AMPS, and with queues it's exactly the same semantics. Okay, we have subscribe. I just want to subscribe. As data comes in, send it to me. Okay, I have sal and subscribe. Actually do a query, atomically query the database, send me all the results, and then when you're done, send me all the things that match as they come in live. Okay, we call that sal and subscribe. State of the world and subscribe. It's atomic, it's pretty awesome. It's probably the most used feature, one of the most used features in AMPS. I'll get to you in a second. Okay? And then we have just query. You can just query. I just do a query. Okay? Those are the basic commands. There's a bunch of other cool stuff. Delta subscribe, there's delta publish, delta sal and subscribe, right? Or sal and delta subscribe. We do a lot of stuff. I was only talking about queues today. The product does a lot of other things. Okay, you had a question over here?
Yeah, there's filtering. Is that done just the headers part of it? Or the
no, unlike JMS, which is lame, okay? JMS only does property-based filtering. So here's the cool thing about AMPS. I don't care what data type you have, JSON, XML, fix, whatever it is, Google protocol buffers, BSON, whatever it is, we can content filter it, okay, native. Okay, what does that mean? That means we have to parse this stuff. But I will tell you right now, you can send me 500,000 JSON messages a second, and I can parse it, filter it, and deliver it. So we've written our own fast, ridiculously fast JSON parser, right? And when I say that we support all these data types, we support the ones we don't know about either through a plugin API. Okay? We write awesome parsers, whatever, that goes super fast. Other people want to write their own because they got their own special data type. Go at it. If it's not fast, we'll help you actually write it fast. We'll show you how to do it. Okay? Okay? So for example, Google protocol buffers. To be honest, Google protocol buffer, even though it's written by Google, their client code sucks. It's not performant at all. We rewrote it. We wrote our own version of the parser, right? And we're going at, I think it was some ridiculous thing like 10 or 100x faster than what it's doing.
But that limits your system usage, right? Suppose if I have some weird protocol.
No. Here's a cool thing. We also support composite message types. So if you want to do what JMS does, you could actually do it with a composite message type. And a composite message type is multiple message types ganged together. I've got a JSON piece followed by a binary piece. I've got a JSON piece, then I've got a little XML, then I've got a binary piece. And the cool thing is you can write your SQL access to get to any part of it. So one of the things somebody mentioned earlier, I think Eric, was our SQL is a little funny. We replaced the column name with XPath locator. Not XPath, XPath locator. And if you're not familiar with XPath locator, it's /A/B/C. It works for any object type, okay? And we support array semantics as well in that, okay? It's pretty powerful. So I could get, if I have a JSON piece with a binary piece, I can do that's kind of like properties, okay? The cool thing is it's actually your data as opposed to this artificial thing, okay? Which I think is a lot more interesting. Any other questions? Yeah?
In that data model, it's basically nested data structure.
Yeah.
You also support fixed size arrays as part of your paradigm?
Fixed size arrays?
Yeah.
Well, we support, JSON and BSON have arrays. Well,
Yeah.
BSON doesn't really have arrays, but JSON does.
So you
Yeah, we
can
support
be
that.
something like Ace
Yeah,
or
absolutely.
X.
Yeah. Yeah, absolutely. It's hard to do, and we've done it.
Yeah.
It's not easy. Let's see. This is all the stuff we do. I didn't come here to talk about all this stuff, although it's super cool. We support historical replay. I didn't even get into queues are just one manifestation. Let me come actually to one point. Remember earlier I told you that one of the deficiencies of queues where it's destructive. Once I take a message, it's done. Let's say I want to go back and I want to backtest a bunch of stuff and I want to relook at all that data. The coolest thing about AMPS is, remember I told you, you're not publishing to a queue, you're publishing to a topic, and then that's filling in a queue. Guess what? We have that data in the transaction log. So I don't want to go subscribe to the queue. I'm just going to subscribe to the underlying data. Maybe it was published on topic order. So I want to go subscribe not to the order queue. I want to go subscribe to order as a topic, okay? And I want to tell it, I want you to go all the way back in time to the epoch 0 and just replay all the data to me. That's amazing. So basically the data isn't gone. Because what I'm doing here is I told you that queues are just an abstraction. It's an artificial thing. It's how people want to actually do things. But the underlying data shouldn't have to vanish. Okay? And in AMPS it doesn't because we didn't publish to the queue, we published to a topic which got stored in the transaction log, and the queue is just a view onto that transaction log. Any other question?
Yeah, so during the replay, does the subscriber send something like selector kind of a thing saying matching pattern?
Subscribe, it's a subscribe. The only addition, as I say, I give it a dimensionality of what we call a bookmark. A bookmark is a moment in time. It could be a timestamp, it could be an actual bookmark that we've delivered you, and it says, I want to subscribe to that point. And the bookmark could be epoch 0. It could be now, right? That's the typical subscribe, it's just now, okay? Subscribe at the head of whatever the message flow is, okay? These are all the things that people do. Again, demo time, okay? So we produced a pretty awesome demo. So I actually asked my partner, Brand Hunt, to come up here and actually do the demo. Come on. Brand put this demo together. I think it's pretty awesome. This demo, unfortunately, doesn't show queues. It shows some of the performance capabilities of AMPS, and I think that the data around it is pretty. So why don't you take this? I'll get the data. I'll get the demo split up. Here, take that. Can you hold that for me? No.
Okay, cool. So we were looking for a demo. I don't know if you guys, did you see our blog article today? No? No? Okay, cool. So the we were picked up by Data Science Unicorn. It's a publication apparently. I don't know. But it's pretty cool. So so I don't know if you guys, has anybody ever put together a demo that involved data? It's hard, right? Like finding like cool data that people are interested in. I mean, you can do like weather data. Weather data is cool. There's probably weather data people here. But I searched like for the like a month ago. I went on like this like scouring the internet for like the coolest data. Like who's doing like cool data stuff. NFL's not so cool, right? They're doing like I think you can get like 30 years of like plays or something like that. Like this is like, but it's not like any kind of like positional or any kind of like time series data component to it. It's not really. It's pretty dull. But the NBA, I don't know if you guys know this, but like since 2013, right? On every NBA court, there's 6 cameras above that are tracking at 25 times a second every object on it in 3 dimensions. That's awesome. The problem is the data is not public, right? You have to actually scrape the data and stuff. There's if you check out our blog article at crankuptheamps.com, there's a link to an article that shows you how to scrape it if you want to. But it's like anyway, it's super awesome. So imagine like you have like 10 people on the court. You have a ball. It tracks the ball in 3 dimensions. It actually has like track the radius. So when they do a shot, you can see the radius increase and go down like at 25 times a second. That's pretty cool. So anyway, we put together like a small like streaming demo. And if you guys, I don't know how many people are on Wi-Fi right now. Did anybody get the Wi-Fi password up here? I kind of want to find a breaking point of this M4 extra large in AWS. If you want to help, but you just go here and you basically we're gonna try to do a replay. I want to see when it actually breaks. But anyway, so you can choose. The cool thing about AMPS is you can basically choose a replay. This is using our JavaScript client that actually hasn't, we're not shipping yet, but if you want to steal it, it's like on this website.
One thing we should mention here, so what Brand is doing, by selecting a game, okay, that actually game, he's got this thing all set up already. Each one of those, you can think of it as a bookmark. We have this transaction log that's 30 gigs of data. Okay, we actually have terabytes, but we just brought 30 gigs. Okay, 30 gigs of data, okay, and he's basically picking a point in there to start replaying. It's a certain game ID.
So this is a game from 2013, right? So you can see the players like bouncing around everywhere. They're going a little fast. Like that's AMSA. AMSA is like anyway. It's more fun to watch basketball through AMSA. Having spent the last month watching this, sorry, like last week for the visualization, but it took me like funny enough, it took me about 12 hours to put these pieces together. It took me about 3 weeks to download the data. I mean, there's 6 billion data points in 2 years. It's a lot of data. It's a lot of data. It's roughly about a terabyte raw gzips, if you want to do it. So you would take your time and kind of throttle it so you don't get kicked off, because they will blacklist you. You don't want to do that. Anyway, if you guys want to hit this website, did you guys get the URL? Replay, because I've got to
take down the Wi-Fi, I think, too.
Well,
so the other thing is, so this thing is running.
Yeah.
This thing is running on an AWS instance. Okay, right? Who knows where that's running? Probably in. Where's it running? Do you think?
This one is
Virginia.
Maybe Northern California.
Okay, Northern California, and this is WebSockets essentially over the internet, updating this, and I think it's running. And you can look at the rate here, and I think this is updating about 4,000 a second. 6,500 a second. Okay, and when we run this, like when I run it at home, I can get it up to like 30,000. So basically, getting over the internet from this AMP server, 30,000 events a second, and we've actually tried it with 10, 20, 30 clients, and we can sustain those types of rates. That's a lot of data that we're pushing around. Okay.
It works on mobile too.
Yeah. What's the URL?
Yeah, what's the URL?
What's that? Replay.demo.crankuptheamps.com.
So what kind of APIs you have? This one is a
Oh, wait, how's
JavaScript.
it built? Okay, so I download the data. It's all JSON. You can, if you look at the source code, you can probably figure out how to get the data out of AMPS. This is only I only put 20 games up here, right? Because I don't want to pay like $30,000 next month to Amazon. Because it's a lot of data. I mean, that you can see the stream up there where the replay is going. As people start hitting it, it's a little more jagged on my phone. Is anybody else doing it on a mobile device?
Yeah, it's jagged.
No?
Say yes, it's
Oh,
just.
he's whipping it out. Like, cool. No, he's not gonna check it.
Yeah, it is.
Yeah, you doing it on your mobile device? Is it really jaggedy on top?
A little bit.
And unfortunately, it's still working. I don't know the breaking point. Anybody else gonna help me out?
Wait, I'm sorry, what's the URL?
It's a replay.demo.crankuptheamps.com. It's weird. It's four level. I wish I had a marker. But at some point we'll have to break. Well, it'll break. I don't know what I haven't been able to do it. We had like I don't know, like
30,
60 or something.
Yeah.
I don't know.
But
And there's other people on it right now too. I didn't have time to implement the counter of how many concurrent replays there are. But there's a few people. Who's doing it? Is anybody doing it? We got like that's 8 or something like that. How many are you getting over there? Oh, you're on mobile.
He got a different game.
What's that?
This is his software. He got a different game.
A different game. Oh, you clicked on a different game. That's
Oh,
what's
yeah,
cool.
yeah,
You can do so. You can do full content filtering
LA
basically.
Lakers versus.
Jeff wanted me to do per player like filtering and stuff like that. I'll do it. Oh, the green things. That's obviously a shot made.
yeah, so I mean,
The red ones are.
some of the things that we can do with this that we show the capabilities is this is just a replay, say, of a game. What we can do is we can add a content filter. I want to do a replay of game XYZ only where the player equals X. And we can just see that one player moving around the court. So that's the content filtering, where the content filtering comes in. We're actually on the server filtering the data and only sending that data.
So right now there's no filtering for your queue, right?
No, we have filtering. We don't have any in this demo. In this demo, we're going to add that.
Okay, so what we see here, the queue is pretty much the same as your underlying
Absolutely.
Okay.
Yeah.
And every client is a subscriber, so you have one queue right now.
No, so this, what you're seeing here is just a straight replay network. No queues.
Oh, there's no queue.
No, a queue is a one-take model. It's a delivery model. This is a, I just want to subscribe to the data. I want to get everything I subscribe to. It's not a queue.
Okay. So it's directly hitting the underlying.
Yeah.
Okay.
It's going against the real data. And it's 30 gigs of real data.
Okay.
This actually looks really good on mobile, on over LTE.
Yeah, it's pretty good.
There's no jitter here or stutter or anything.
No, thank you. I don't know if anybody's seen the visualizations, but so it's using D3 for the dominant. Oh, sweet. Oh no, I think I just replayed it all.
Yeah.
Yeah, it's finished.
Ran out of data. That was the game. The game was over.
Yeah, what?
Yeah.
I want to find the breaking point. I actually haven't.
I was saying, did you try putting it on Reddit?
I don't know. If I have to find like a sponsor, I think, for the bandwidth.
Yeah.
But that's a good idea. I'll try. Maybe I'll try it. Maybe I'll.
The funny thing is
Money
my
on
phone's
all
getting
it.
hot.
What?
My phone's getting hot.
That's
Yeah. Amps makes an iPhone 6S hotter. Anyway, so it uses D3. That plotting component up there is like something 3 years old. Never had like it hasn't had a GitHub like update in that many years.
But the earlier question about the source. So if you go and show source, all the code is there.
So this is
I didn't
using the
minify it either.
JavaScript
I'm not
API to, so from the AMP's like client perspective, is it like JavaScript API that is using, or?
Yeah, we have a JavaScript client. We haven't released it yet, but it's in there. It's in there. This is a very simple JavaScript client that talks to AMPs. The beauty of AMPs is it's actually pretty simple from an API perspective. It's connect, subscribe, publish.
Or all.
You know, it's pretty simple.
Is it? I guess it has a native website.
Like the Sacramento Kings.
We have native websites. It's ridiculously fast. No, I'm seeing it's insanely fast. Look at this. I mean, this is all WebSockets, rough pressing. Again, I've actually looked at all the WebSockets implementation, and they all suck.
What did you say about WebSockets? You're not a fan?
We wrote our own. Yeah, I mean, we just, we can't use other people's stuff while you're
You probably have an email from your phone company.
Oh, you do? We don't need high-end hardware. We're running this thing on AWS, come on.
It's an M4 extra large.
It doesn't have a lot of CPUs, it only has like 4 CPUs.
Yeah.
What, our main business? What about?
Oh yeah, investment banks don't run on AWS.
Yeah. Most of our clients are investment banks. Yeah, question.
So right now you don't have a queue, but what if I'm only interested in one particular player? You're going to construct a queue, right?
No, we don't construct a queue. You can think of it that way. What we're going to do is you're going to say, I want this game, or I don't even care about the game. I just want all movements of this player.
Yeah.
Okay? And if you want to start the very beginning of the data, we'll start there and we'll just go search that data essentially.
So you don't cache anything, you don't even maintain a reference to the underlying stuff?
No, I don't want to talk about how we actually implement that to make it insanely fast, but it's good.
It's not that exciting.
Yeah.
A lot of engineering hours.
A lot of engineering. I mean, we spend a lot of hours.
Optimized for sequential reads.
Yeah.
So does this put like on-demand update to my subscription criteria? What if I want to for the same subscriber, I change my criteria for the
You can do a replace.
You can replace your content filter. Yeah.
So it's gonna rerun the process and then generate a new.
No, from that point forward. If you want to rerun it, you basically start over from scratch with a different process.
Remember, I told you you can pick where you start. So if you left off at, let's say, bookmark 100, whatever that is, and then you say, you know what, I want to change my mind and I want all things for this guy, but I want to start at that point. You send us that point, and we'll start from there and start the filtering process.
Does it rerun the process to generate a new view?
No, it doesn't have to generate a view. It's doing it in real time. It just goes and starts and just does it. It doesn't have to generate anything.
So, but it's guaranteed, like, even though the underlying queue is huge, you can still do it in a real fast.
Yeah.
Yeah, it's really fast.
So it's like
fast.
two sockets communicating on
In
the
fact, it's so fast that one of the things the code does is it throttles the sending of the data, because usually we're too fast for the clients. So we throttle back the data that we send.
So the only latency in this is essentially the network latency and the
network.
local bus, right?
Yeah, the network and the local bus. Yeah.
I mean, so here, it's sort of true. I mean, there's now watch what happens. So if I go here, I mean D3. Have you used D3 before? Like yeah. So D3 is it's not about visualization. It's more about just like DOM manipulation, right? And we trick it to do stuff. Now you see how much the performance increased while I had it hidden, right? The performance is much higher when I have it done. So 25,000 messages a second over Wi-Fi on this laptop. It's a nice laptop.
Thank you.
It's really nice.
So nice. You have one just like it.
No, this is but anyway, so you can see like so the biggest part of latency is the message handler, right? It is basically responding to those messages. The gentleman over there said that that's like the coolest way to program. Basically just event-driven program.
Would you be able to reiterate that? Because I couldn't hear.
Oh, you couldn't hear it?
No.
I mean, it sounds like instead of having like a get model where you basically pull data out of a server, like a SQL query or like a get from a queue, right? Instead of doing that, it's so much better to like basically design a system where your client can basically just register a handler with the server event. It's kind of like how a lot of like cool, you know, I mean, Facebook and Asana and stuff like that are all built on technologies like this nowadays. Like web technology. It's like comment. It's like you're getting push data like over. It's like we don't use long polling here. We use
It's like
WebSockets.
one never-ending message, basically. Right?
Yeah, it's a stream, right? We use WebSockets because in the world where we typically deploy things, right? It's fast-moving data. It's like 25,000 messages a second. You're not going to do that through long polling, right? It takes you a long time to set that session up, and like it's just long polling is request response, right? We don't want to do that. So the gentleman over there in the blue shirt, what's your name? Yeah.
Enzo.
Enzo?
Enzo. E-N-Z-O.
Enzo. Oh,
Enzo.
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 With a Z.
With a Z.
All right. So Enzo over there was making the point that basically it's cooler to basically register your client-side message handler with basically the server and basically just be delivered events as they come in, right? The cool thing about that is that AMPs can detect when that client is slowing down, right? And it can pace the delivery of those messages so that it doesn't use a ridiculous amount of resources. Now WebSockets in Chrome has a defect that I really want to fix, because if you're in here and you like hit pause in the debugging environment, it continues to receive messages in the background, and it like slows your entire system down. It basically becomes I probably wasted like 2 hours of my 12 hours of building this on that, unfortunately. But anyway, did that make sense? Like, so just build it so you just basically get events. It's just event-driven programming. Like we did in Visual Basic in like 1994.
Okay.
But
Question for the audience. Do you think we succeeded in reinventing queues?
yeah.
Come on. Absolutely. If you look at every feature we have in our queuing system, okay, we basically redid the whole thing. Okay? We didn't take any of the old assumptions about queues and run with them. Whether it's filtering, I mean, nobody does filtering of queues. It's put get. That's it. I get. Oh, it's not the thing I wanted. What do I do with it? I'm in a queue series. I abort the transaction and let it re-deliver to somebody else that may want it. Okay? It's not nice. Okay? Pipeline, concurrency. Okay? Again, solve. Replication, solve. Okay? In much better ways. And then performance. 18,000 messages a second may work for some things. It doesn't work for a lot of other things. It's pretty minimal. Okay. Any final questions? Yeah?
How can we start using this?
You can download it. Try it out.
All right. So what do you deliver just a binary? Is
Okay.
that?
So let's just give the status of the product. It's a good one. So today, we have. So we talk about version 5.0. We have not officially released this yet. However, if you send a note to support@crankuptheamps.com, we will send you the URL to download. Okay, so it's actually in pretty good shape. Lots of testing. We have just a few more features to add. But all the queuing stuff that I've described today pretty much all works. We've already tested it all. The things that we're adding are different things. Okay?
Yeah. Oh, you know basketball. You know,
okay.
Did you really want to see like on the court?
Well, he's a coach now.
He's a coach now.
He's a coach now.
I actually need to look that up because I thought I had a data.
Okay, so the product that's in the market today is 4.x. Okay, you can download that. That's the one that's on our main site, crankuptheamps.com. But if you send a note to support@crankuptheamps.com, we'll give you the URL to get version 5, if you will, preview, if you will. Yeah.
You said your customers are
Mostly investment banks, yeah.
What can you talk about their experience with it and what they're seeing?
So it's a wide spectrum. So we have one large bank. It's kind of insane to talk about them in the sense that they have close to, there's a couple different counts, but upwards of 2,000 to 3,000 AMPS instances deployed.
In production.
In production. Pretty massive deployment. We have some newer banks that have, tens of AMPS instances. You actually might say the great question that I think people should ask is, 2,000, I thought the thing is really scalable. Why do they have 2,000 of these things? Because they stovepipe things. Each application wants their own instance for their own stuff. And they have lots of applications. So that's why they get so many. It's not because it's not scalable. The earliest production instance we have is 2008. That system is still running today and running really well. We don't run into a lot of performance issues. Okay? We mostly run into issues with the user's own equipment. Their network's not tuned or whatever. AMPS actually will work fine, but since AMPS can be measured well, they usually say, oh, AMPS is the problem. No, AMPS is actually showing you that the problem exists. Okay, that you have latency somewhere in your network. Okay, it's not inside AMPS. Does that answer that question?
Sure.
Well,
And we got feedback today from one of our biggest customers that said AMPS is the fastest and best component in their entire stack. Which made us feel good.
Yeah.
I feel good about that. We didn't give them a hug afterwards, but
Yeah, we should have.
Yeah. So what's the dependency on the database?
Database is internal to AMPS. There is no dependency. We built our own NoSQL SQL lock-free database. Totally different than all the NoSQL things out there because we actually support SQL. But we call it NoSQL because it's objects. So you can store JSON objects. Now some of the coolest things you can do, we talked about aggregations and joins. I can actually take JSON data that's in one topic. I can take fixed data that's in another topic, and I can actually have a join of those and produce BSON data. Okay, I can do that all in our engine. Okay, it's pretty awesome.
I was wondering about that, but I want to ask, but since the gentleman asked, that means that besides all the parsers for expressions, which is not that hard to do, you also wrote your SQL optimizer, the query optimizer, and heuristics and all that.
It's funny.
I
I don't really have an optimizer.
Yeah.
I don't have one.
We don't have one. For
No.
the queries, for the SQL.
we just start fast.
We're believe me, it's fast. So we did a comparison. I'll give you an example. One large investment bank, they put us up against MongoDB, and it was slaughterhouse. Just killed the thing. No, I'm serious. It was simple. It was a simple thing. A million objects. Okay, load them and then do different types of queries. One query, get back 10,000 of them. One query, get back 10 things or 100 things in each query. Okay, hold on. It took minutes to load MongoDB. Okay, it took a second to load AMPS with a million things.
It's an unfair, a bit academic follow-up question, because I personally don't feel the need for these things very often. But people are asking like, so queries, inside SQL you have a query inside the query, very complex joins, all this stuff. Then you start hitting problems and key complete problems of optimization. You just have a heuristic, you do well enough.
Secret sauce.
All right. Fair enough.
Highly concurrent, we take advantage of the entire machine. We do smart data placement for Numinous, all the same things. We do it, in fact, a lot of things. We do things that most computer science professors would never teach you to do because they think it's wrong. We think it's right.
As a application developer, how would you advise me if, let's say, I'm thinking about using MongoDB for a feed, or I'm thinking about using RabbitMQ? Should I just always use AMPs?
Oh, you'd use AMPs. Definitely. No, when you start to see that, first of all, the APIs are much better. How you interact with the system is much better. What it can do for you is much better. Just the fact that I can offer you both replay of your data and queue of your data in the same system at the same time, okay, is pretty spectacular.
So there's no application you would recommend using MongoDB over AMPs like I do?
Oh, I'm sure there's one or two. But no, I mean, look, I mean, we've designed, I mean, I come from Wall Street trading world, and I used to see every application need 3 or 4 different things. And what they would do is they'd go get some messaging, they'd go get a database, they'd go get this, and they'd go get that. And then they'd stitch together a system. The problem with that is, what I observe with the problem is, none of it ticks together. It's all, you have to, basically as an app developer, I have to correlate all that. So imagine just atomic silent subscribe. I want to go get the state of the world, that's why it's called state of the world. I want to go get the state of the world, and then I want to get real-time updates. So imagine if you only have a database and a messaging system. What do you have to do? I have to go query my database, I get a bunch of results back. Now I have to go join the real-time stream, and then I got to figure out where they intersect or overlap. Why do I have to do all that? I just want to do silent subscribe. Give me the state, send me real-time updates. That's awesome. I want then a P&L view as my data ticks. I want the P&L to tick too. I want that updating constantly. So as I get messages, my P&L is also ticking, and I'm subscribing to that.
So are you saying, would you replace Postgres with AMPs too? Or?
I don't know. We're not really trying to compete with Oracle or DB2. Those have a place in the world. But what we're doing is real time. We want to be much more real time. So, there's a philosophy that old style databases, they're good at, you fill them up and then you query them. You fill them up and you query them. They're not good at real time. They don't do real time. Every time, it just goes back to, we're a real time streaming database, okay, with a bunch of other capabilities like queues and whatnot. And so when data comes in and you update the database, the view is also updating too. So the two are in lockstep.
So if I was going to build a social network with a feed, I'd still want to have a Postgres to store the users and stuff, and then maybe use AMPs.
No, you could store the users inside AMPs. Yeah, because you then write a component that every time a new user comes into the system, you're getting notified. Why do you have to query that? Oh, I'll query every 3 seconds. I'll just do a query and get new users. With AMPs, you wouldn't have to do that. I start up, I go get all the users that exist today, and I subscribe at the same time. And then my thing is just sitting there waiting as users come in, and I have new users that I know about. It's a much better model.
So you wouldn't use Postgres for something like Facebook? You would just use AMPs?
I wouldn't, no. But I'm non-traditional. Okay.
That's cool.
In all the cool ways, not the bad ways.
So, just to get this right, you're logging whenever it enters the queue, whenever it leaves. So that's like what? It's 500,000 messages a second. That's 1 million transaction logs a second.
No, our transaction log, this is the other place where we're different than, say, something like Kafka. Kafka, in my mind, there's a lot of brain dead things about Kafka. And most people only find them out after they've actually deployed something. Okay? We're the only product that I know of now that basically says the order in which things happen actually matters and is useful. So with Kafka, you have to partition your data. I've got orders over here, and executions over here, and positions over here, in different shards, if you will. Problem is that these things happen in some kind of time order. And timing is notoriously bad. So actually what we do is we have one log. We don't have a log for orders, and we don't have one for executions, and we don't have for this. One. Okay? And it's not one file. It's actually a sequence set of files, so we have units of whatever. And as things come in, we write them. The coolest thing about this is when you do playback or subscribe, I can guarantee you that the order in which you get things is always exactly the same. Because I've recorded it in an order. And once it's been recorded in that order, I can always give it to you back in that order. It's very important for a lot of things. Imagine you're building a trading system or any system, and I have these 3 disparate partitions. And one is moving fast, one's moving slow, but it's because of the infrastructure. And now I'm getting them in some order. And I say, you know what, start over, reset everything. I'm gonna get them in a different order. And so I have to sit there and figure out, oh, do I take the timestamps of each thing and I correlate them and do all this stuff? None of that. You don't have to do any of that with AMPs. It just makes it so much easier. Does that make sense?
Yeah, and then you offload that at like a periodic time. Like,
what do you mean offload?
Like, for example, these AMP servers are in production. If you're writing like 1 million logs a second, when do you run out of data and then like put it into like a archive?
Awesome question. So inside AMPs, another cool feature we have a little cron scheduler. Okay, we have a little cron scheduler, and you can set up compressed journal. Okay, archive journal, remove journal. Journals are the transaction log is made up of journal files. Okay, so you could actually set something up so every 5 minutes it's compressing them, and then every day it's moving them off to an archive. Now, the archive is just another location, but we still know about the entire set. We still see the entire set of them. Okay, and then you can remove them. So after 24 hours, I don't care anymore, just get rid of it.
So how do you, everything, it sounds like it's a vertically scaled thing, right? So
it's a good what?
This is a vertically scaled thing, right? It's not.
Oh, it can horizontally scale too. It does everything. No, I'm not selling magic. No. So this gets to a philosophy. We believe that too many things today just scale out. Shard, scale out. Well, with that comes complexity.
Of course.
Okay, so our philosophy is scale up as high as you can, because we have a lot of CPUs, we have a lot of memory, we have a lot of fast storage. Scale up, use that box to its nth degree, and only then scale it out. So that's where replication comes in.
Oh, because there is that component.
Oh yeah,
okay.
You can replicate, you can partition, but you maybe can partition at a higher level.
Right.
Okay, we have people that are doing this. We have people using it as a globally distributed message bus, so they have it all over the world, and it's replicating, and we know how to terminate replication so that it goes from A to B to C to D, and it doesn't go back to A because it knows that A was the origin of the message.
So how much does all this cost?
What? It's negotiable. So your firstborn and his thirdborn.
Obviously, there's a licensing model there.
It's a subscription-based product. We think it's very fair and reasonable. We can discuss pricing, whatever. But yeah, we didn't go the open source route. A lot of people, I'll tell you right now, open source is awesome. Linux is about the best open source thing that's out there. A lot of other things are pretty crappy.
So
you
if
get what you pay for.
Right. But if I download,
you want to use 100 servers to do what you could do on 5 servers, what costs more? I've got free software, but I have to use 100 servers to solve my problem. I paid for software and I can do it on 5. It just depends what you want to do. A lot of people who employ it have 100 servers too.
But the binary that you're making, the binary that you'll make available to,
yeah.
If send a
what about the
nice
binary?
email.
You can download it from our website right now.
Yeah.
But is that free for a certain amount of transactions?
We don't really monitor
limit it anyway, right? So most of our customers, like investment banks and stuff like that, they forbid you engaging in self-help. I don't know if you know what that means, like legally, but you don't put time bombs and shit in it because they don't want that to ever go off, right? So yeah, you can download it right now and use it forever.
Yeah.
Do you want to? I mean, if you want to do it without support from us, that's fine.
Yeah, so everything for us is about supporting the product. So you want to use it in a production system. Nobody puts stuff in production they really can't get support on. It's just a bad philosophy.
No,
and the question is, what do you want to pay for that support? Which makes it really no different than buying Mongo support or buying Redis support or whatever you want to buy, or Linux. I mean, every bank on the street uses Linux as open source, but they all pay Red Hat or somebody else to support it. I mean, it's open source, oh, it's free. Well, not if you want support. So it's a support model for us. If you want to download it and use it forever, go ahead.
Well, I don't have a bank, so.
What?
I don't have an investment bank.
Okay.
Just curious about the.
Do you have a bank account?
You want to know if you should stop talking to me or not?
Publish it to me, please. I'll put it in my transaction log.
When you guys did a demo, it was pretty cool. I like the proof of concept about the
taxis.
Yeah.
Yeah.
Did any company use a proof of concept into an actual product?
Yes, our competitors.
No, it's very funny. All of a sudden, a bunch of competitors showed up with that exact demo.
Wait, what was
Really?
the demo for those of us?
Last year we showcased, so last year we were launching AMPS 4.0, and the big selling feature was basically historical style and subscribe, right? So the ability to basically time travel back and get your data. So this is sort of like time traveling right here, right? We're doing a replay. But the cool thing about that is, are you familiar with like Oracle flashback queries and these other things where you can basically do a SQL query against a table at a specific moment in time and see what the data was like at that moment in time. Right? AMP supports the same thing. You can do historical style queries, the database query for it, and you can replay forward, right? So you can, if you want to like look at like the state of all taxis within New York City at a moment in time, right? You do the style query, it basically tells you that, and you can start playing forward to see how the taxis transition through the city, right?
Yeah. I'll give you a concrete example. So historical style and subscribe. So think of it as kind of a little bit of a time series database and a state of the world. So I'm a trader, I'm looking at my portfolio. I get a phone call from the guy who says, you know what did my portfolio look like 2 hours ago? I can't do a state of the world because that's the current state. So I want to do, can you show me a state of the world from 2 hours ago? So it does a query as if it was 2 hours ago, gives you that result. And then if you do a historical style and subscribe, it'll start a replay from the last, just past the last thing it was included in that query. So you can actually do back testing. I can say, let me start with my portfolio at 2 o'clock, and let me see what happened over the last 2 hours to get it to 4 o'clock. That's a pretty cool feature.
So next year you'll see that what we have planned for 6.0, you'll be talking about this demo.
Oh, awesome.
Yes.
Yeah, no, that's cool actually.
Yeah.
Do you guys have a Ruby support?
Not
We
yet.
do not yet. You want to
Build
build
it?
We see, we just went open source on you.
Our clients are open source, by the way.
Yeah.
So we give you the code to those. We just don't give the code to the server. There's too many gems in there. Yeah.
Any of your clients has used the feature we were just describing to backtest day trading algorithms?
Absolutely. Absolutely.
You must work in finance.
I did. I'm an entrepreneur now. Actually, I'm here because I want to build this products that are complementary to what you do. They can benefit of relying on messaging queue.
Yeah.
Awesome.
And replay, ridiculously fast replay that I can't break. Is the T-Mobile guy still here? No? Oh, too bad.
I have T-Mobile.
Any other questions?
Oh, yeah. Are you only getting like 100 messages a second?
Okay, so do you guys all know what AMPS is now?
Yes.
Yeah.
Okay. Do you think it's as cool as I think it's cool?
Yeah.
Okay. And we're super cool.
Yeah.
So we'll hang out for a while if you guys want to chat. But thanks. It's been really I appreciate your attention. Yeah, please. If you want a T-shirt, it's a cool T-shirt. It's a really cool T-shirt. Kids love them.